Hello class, and today what we are going to do is, today we are going to talk on the research methodology. Okay, so uh, let's start with it. Today is the first part of it that we have. So our learning objective is where we get to know the difference between research methods and methodology, the research design, what you mean by it, the types, the measurement of variables and scales, and sampling. So let's start with the difference between research method and research methodology, right? Research methods, it's these are the actually we're talking about the methods that the researchers actually use for collecting data in order to conduct any research with regards to your particular research area. Whereas research methodology, it's a systematic approach to solve the problem and to come to a conclusion. Objective for research method is to find a solution, whereas the objective for research methodology is to determine the solution, which is the right solution, by applying correct procedures of research. Research methods are useful to apply during the later stage of the research process. For research methodologies, it's applied at the initial stages of the research process. And which from this you actually get to know that research methods are a part of research methodology. Methodology, on the other hand, is a multidimensional concept. Research methods consist of various techniques where you have various studies and experiments are done. They're used to conduct the research and to come to a proper conclusion. Methodologies are usually used during the initial stage of research to actually explain the purpose for choosing these methods and how they will serve its function. Methods, they consist of different investigation techniques. Methodology is a systematic strategy to achieve the desired objective. Research methods, it includes the process of carrying out an experiment, survey, test, and so on and so forth. Methodology, that includes different techniques which are used during the performance of the tests and surveys. So method is where we choose the technique, right? Choose the technique that we use in the research, and methodology is the logic behind choosing that method. So this is how the research process is, how it goes. Now, the first thing that comes up is you have your observation on the broad area of research, your research broad area of research, which you need to identify. And from there comes up where you need to do a literature survey to identify the main problem, right? And then you work, study more on it. That's the critical literature review. So from there, you actually design your theoretical framework where the variables, you can identify clearly the variables which is required for your research, what are the variables which is involved, and then you from there you deduce your hypothesis, and then once you deduce your hypothesis, then you have to design the right kind of research design. Based on your research design, you go for data collection, analysis, interpretation, and then comes up the deduction and the induction. The induction is where you check whether your research question is answered. For deduction, it's not just your research question being answered, but also whether your hypothesis is being validated or not. If it is not done, then you start the entire process once again, where you find out the research problem and you do the entire process till you come to yes. Okay, only when your questions have been answered, then you start writing the report and present it, right? Based on which the management makes their decision. So, what is research design? This is where we are talking of in this unit. It's a set of methods and procedures used in collecting and analyzing measures of the variables which is used for the problem, your problem. And so the design, it actually defines the study type, right? Where we talk of descriptive correlation experiments, what could be like longitudinal case studies. These are things which is used for identifying the research problem, hypothesis, independent, dependent variables, experimental designs, and if applicable, data collection methods and a proper statistical plan. So research design is a framework that has been created to find answers to the research questions. So what is research design? It is refers to the overall strategy that we choose to integrate the different components of the study in a coherent and a logical manner, which would ensure that we can effectively address the research problem. And so it becomes the blueprint for collecting, measuring, and analyzing data, right? So you need to know one thing, that your research problem determines the type of design that you use, not the other way around. Based on your research problem, you decide what sort of research design you would choose. So research design is the framework of research methods and techniques which is chosen by the researcher, which allows the researcher to develop their skills in the research methods that are suitable for the subject matter and set up their studies for success. So, the research design, it explains a type of research. Okay, what are these? Like experimental survey, correlation, semi-experimental review, and also some subtypes, that is experimental research problem, descriptive case study. Basically, there are three main types of research design, that is data collection, measurement, and analysis. The type of research problem that the organization faces will decide the research design, and the design phase of a study that determines which tools to use, and not just which tools but how to use it. So research design actually helps to create a minimum bias in data. So it reduces the biasness in data collection, and it also increases the trust in the accuracy of the collected data. A design that produces the least margin of error in experimental research is generally considered to be the best outcome. So the elements, essential elements for any research design is, first is to have a proper purpose statement, then to determine the techniques that you need to implement for collecting and analyzing research, the method applied for collecting these data, for analyzing the data, type of research methodology, the probable objections for research, the settings of the research study, timeline, and measurement of analysis. Now, proper research design sets your study for success. Any successful research design that helps in providing insights that are accurate as well as unbiased. Okay? So there are four key characteristics of research design. Neutrality, like when you set up your study, you may have to make assumptions about the data that you collect, right? So the results projected in the research design should be free from bias. I repeat, okay? Neutral, free from bias and neutral. So understand the opinions about the final evaluated scores and conclusion from multiple individuals, not one, from multiple individuals, and consider only those which you agree with the derived results. Reliability. While you're regularly conducting research, the researcher involved, they expect similar results to happen every time. Okay, so your design should be such which would indicate how to form research questions, which would help you to ensure that the standard of results, right? So you'll only be able to reach the expected results when, if your design is reliable, trustworthy. Next comes up validity. Now there are multiple measuring tools available, but the only correct measuring tools are those which helps you as a researcher to actually look into the results, where you'll be able to analyze the results and according to the objectives of the research. So the questionnaire developed from this design will then be valid. Generalization. Now, the outcome of your design should apply to a population and not just to a restricted sample. The entire population should come into play. So, a generalized design, it implies that your survey can be conducted on any part of the population with similar accuracy, right? And these factors affect the way how your respondents answer the questions. So, and hence what happens, these above characteristics should also be balanced in a good design. Functions of a research design. What is the main function? To ensure that the evidence obtained uh, enables you or helps you to effectively address your research problem as unambiguously as possible, right? So in social science research, what happens is obtaining evidence relevant to the research problem generally helps you in specifying the type of evidence needed, test a theory, evaluate a program, or to accurately describe a phenomenon. Okay, but what happens is researchers can often begin their investigations far too early before they have actually done a critical review about that regarding the information that is required to answer the research questions. So without attending to these design issues beforehand, what happens? The conclusions that is drawn, that becomes risky, it becomes very weak, and it is unconvincing. And so what will happen? It will fail to address the overall research problem. So now, given all this conditions, so whether your research design is lengthy or complex or whatever it is, it can be short, it can be simple, it can vary, but irrespective of the type of your research designs, any design, any sound design should have the following things: identify the research problem clearly and justify its selection, should be able to review previously published literature associated with the problem area, clearly and explicitly specify the hypothesis which is related to your problem, effectively describe the data which will be necessary for testing your hypothesis, and also explain how these data is being obtained. Describe the method of analysis which will be applied to the data in determining whether or not your hypothesis is correct or false, right? So broadly, if we talk of the types of research design, it can be broadly classified into quantitative and qualitative. Now, quantitative research design, it helps in determining the relationships between the data collected and the observations based on mathematical calculations, right? So this is where when we talk of qualitative research design, it actually addresses questions like why it talks about the question why. So researchers actually rely on qualitative research designs that conclude why a particular theory have existed along with your respondents have to say with it, why it exists, and what the respondents have to say about it. With regards to quantitative research design, these are for cases where statistical conclusions are used to collect some actionable insights. Okay, so numbers, what happens? They provide a better perspective, better to make any critical business decisions. And this is necessary for the growth of any organizations. When you have these numbers, what happens? It helps in doing a numerical analysis, and which would be much effective while making any business decisions. So these are if you break down the types of research designs, right? These are the different types of research designs that we have. We'll go more into details. First is action research design, which the essentials of the action research design is they follow a particular characteristic cycle where what happens initially an exploratory stance is observed, where you understand the problem and then plans are made as to how to go for an interventionary strategy. So then the intervention happens, the action is carried out during which time that pertinent observations are collected in various forms, right? So these interventional strategies, they have been repeated in a cyclical process until you get a sufficient understanding of the solution that you want to implement, right? So you get to know better understanding of the problem, and so that you are in a better position to apply the solution. So what do these studies tell you? It's a collaborative and adaptive research design that lends itself to use in work or community situations. It focuses on pragmatic and solution-driven research rather than testing theories. Now, while using action research, it has the potential to increase the amount of one you learn from your experience. So it's basically considered as a learning cycle. These research studies often have, and most of the time, direct and obvious relevance to practice, and there are no hidden controls or preemption of direction by the researcher. What do these studies don't tell you? It's harder to do than conducting conventional studies. Why? Because the researcher takes on responsibilities for encouraging change as well as for research. It's harder to write up because you probably don't understand, you can't actually use a standard format to report your findings effectively. And sometimes personal over involvement happens, which may result into bias results. Okay, and the cyclic nature of this action research, what to achieve that two outcomes simultaneously, that is change and understanding, is time consuming as well as complex to conduct. Second type is case research design, which is an in-depth study of a particular research problem rather than a sweeping statistical survey. It's used to narrow down a very broad field of research into one or few available research examples. So it's also useful for testing whether a specific theory and model actually applies to phenomenon in the real world. It's useful when not much is known about a problem. What do these studies actually tell you? It helps us in understanding a complex issue through detailed contextual analysis of a limited number of events or conditions and their relationships. Uh, Also, it helps in to apply a variety of methodologies and rely on a variety of sources to investigate a research problem. It extends our experience or adds strengths to what is already known through previous research, right? And a wide use of this research design happens or is applicable for examining contemporary real life situations to provide which provides the basis for application of concepts of theories and extension of methods. It can also helps in providing detailed descriptions of specific and rare cases. What these studies don't tell us, a single or a small number of cases offers little basis for actually establishing reliability or to generalize the findings to a wider population because it's restricted. It may not happen to the rest of the population, right? The intense exposure to study of the case may bias a researcher's interpretation of the findings because we are too deeply involved in that particular case. So our decisions can be biased the way we interpret. So that can happen. The design may not facilitate assessment of cause and effect relationships. Vital information may be missing, which makes it difficult for the case to interpret. The case may not be representative or typical of the larger problem being investigated. It may be very much unique to that particular case. If the criteria for selecting the case is because it represents a very unusual or unique phenomenon or problem for study, then the interpretations can only apply to that particular case, becomes restricted. Third type is casual design, which may be thought of as understanding a phenomenon in terms of conditional statements in the form if X then Y. So it's basically used to measure what is the impact of a specific change on the existing norms and assumptions. So it's most social scientists usually use this phenomenon to explain, to actually get explanation or seek explanation that reflects test of hypothesis. And causal effect occurs when variation in one phenomenon, which is called the independent variable, leads to a change or if it has an effect or leads to a variation on another phenomenon, which is a dependent variable. So, what are the conditions which is necessary in this case? Empirical association. That's a valid conclusion will is based on finding an association between the independent variable and the dependent variable. Appropriate time order. To conclude what causation was involved, one must see that cases were exposed to variation in the independent variable before variation in the dependent variable. It has to be independent variable first changes. Non-spuriousness, the relationship between two variables that is not due to variation in the third variable. It has to be only two variables involved, not any third. So these studies actually tell us the following. It helps researchers understand why the world works the way it does through the process of proving a causal link between variables and eliminating other possibilities. Replication is possible. There is greater confidence that that the study has internal validity due to systematic subject selection and the equity of groups being compared. What it doesn't tell us, Not all relationships are casual. The probability always exists that by sheer coincidence, two unrelated events appear to be related. Conclusions about these casual relationships can be difficult to determine why, due to a variety of extraneous or confounding factors that exist in the environment, right? And this means what casualty can never be inferred. It can be only inferred, sorry, but never proven. So, and if two variables are related, the cause can come before the effect. The cause actually should be coming before the effect, but sometimes it can happen like it becomes very difficult to understand that which variable comes first, and so it's very difficult to find out which is the actual cause and which is the actual effect. What is cohort design? It's generally used in the medical sciences but can be also applied in social science. So it refers to a study conducted over a period of time involving members of a population which the subject or representative member comes from and who are unified by some common factors or some similarities common. So under this framework, what happens? You make note of the statistical occurrence within a specialized subgroup united by some similar characteristics that are relevant to your research problem. Okay, and now cohorts, what happens? Cohorts can be either open or closed. What is open cohort study? Open cohort study is where what happens is like we are actually involved, where we talk of a population that is defined just by the state of being a part of study and research questions, and is not being and being monitored for the outcome. Say for example, dynamic population which is of Los Angeles, right? So the date of entry and exit from the study is individually defined, right? Therefore what happens, the size of the population is not constant, right? In case of closed cohort studies, what happens is, for example, like patients who enter into a clinic trial, that involves participants who enter into the study at one defining point in time, and we assume that there are no participants are entering at that time, entering the cohort. So then what happens? The number of participants remains constant, right? Or it can, for maximum, it will only decrease. Open is where entry and exit and can happen at any point of time. So, what do these studies tell you? Its use of cohorts is often mandatory wise because a randomized control study may be unethical, right? So, it's better to have it have a cohort design. So then it becomes easier. Cohort design, what happens? It means it actually measures the potential causes before the outcome has occurred. They can demonstrate that these causes actually precede the outcome. So thereby avoiding any debate as to which is the cause and which is the effect. So it's very easy to find out the cause. You already know the cause, it becomes easy. It's highly flexible and provide insight into effects over time, and it's related to a variety of different types of changes. It's either original data or secondary data that is actually used in this design. What these studies don't tell you, in case where a comparative analysis of two cohorts is made. So in that case, what happens? A researcher cannot control all the other factors that may differ between these two groups. So these factors are called confounding factors or variables. Cohort studies can end up taking a long time to complete if the researcher waits for the conditions of interest to develop within the group, right? Which also increases the chance that the key variables change during the course of study, so thereby impacting the validity of the findings. And because of the lack of randomization in cohort design, its external validity is lower than that of those designs where the researcher randomizedly assess the participants. Fifth design is cross-sectional design, which have three distinct characteristics. That is, there's no time dimension, right? Reliance on existing differences rather than change following intervention. So there already exists a difference amongst the group, between the groups, and groups are selected based on that existing difference rather than random allocation. It can measure only measure these differences between and among a variety of group of people, subjects, of phenomenon, rather than change, right? And as such, what happens is the researchers usually use this method uh, for to when we actually look into making causal inferences based on findings. What do these studies tell us? They provide a snapshot of the outcome and the characteristics associated with it at a specific point of time. And there is an active intervention by the researcher to produce and measure change or create differences. Okay, it focuses on studying and drawing inferences from existing differences between these groups. It helps in collecting data and concerning at one that are concerned with one at one point of time. Okay. The groups identified for study are purposely selected based on the existing differences in the sample. Now, it also is capable of using data from a large number of subjects. It can estimate the prevalence of an outcome of interest because the sample usually is taken from the whole population. Because cross-sectional designs generally use survey techniques to gather data, they are relatively inexpensive and takes very little time to conduct. What these studies do not tell us, finding people, subjects, or phenomenon to study that are having similar, they are very similar, except in one particular specific variable is very difficult to find. Results are static and time bound because we said there's no time element coming in, so which gives no indication of the sequence of events or reveal the historical context. Studies cannot be utilized to establish cause and effect relationships, and it provides only a snapshot of analysis. So there is always the possibility that a study could have differing results if another time frame could have been chosen. And there's no follow-up into the findings. Sixth is descriptive design, which helps to provide answers to the questions of who, what, when, where, and how associated with a particular problem. It cannot give answers to the question why. So it's used to obtain information regarding the current status of the phenomenon and to describe what exists with regards to the variables or conditions in a particular situation. What do these studies tell us? The subject is being observed in a completely neutral and unchanged natural environment. So true experiments, what happens while giving the analyzing that giving analyzable data often adversely influence the normal behavior of the subject. It's often used as a precursor to more quantitative research designs. If the limitations are understood, they can be a useful tool for developing a more focused study. It can yield rich data, which lead to more important recommendations. Approach collects a large amount of data for detailed analysis, so it becomes easier when you are for doing a detailed analysis. What they don't tell us, the results from a descriptive research cannot be used to discover a definite answer or disprove a thesis. Because these designs often utilize observational methods, the results cannot be replicated, and it heavily depends on instrumentation for measurement and observation. Next, experimental design. So it's a blueprint of the procedure which helps a researcher to maintain control over all the factors that may affect the result of an experiment. So while doing this, what happens? The researcher attempts to determine or predict what may happen. So it's often used where there is time priority in a causal relationship, where cause comes first before effect. There is consistency in a causal relationship. Cause will always have the same effect, or will always have the same effect, and the magnitude of correlation is great, right? So in case of a classical experimental design, it specifies experimental group and a control group. And the independent variable is administered to the experiment group, not to the control group, and both groups are measured on the same dependent variable. So you bring in change in one group and see how the other group remains as it is, and then you see the effect. Say if there are two groups, and you give apple a day to one group and see what happens. Do not give. So what happens? One group, the group which is having apples, may actually result in not going to the doctor less number of times compared to a group where it's You're not controlling it, so you do not give and you see what happens. So that's a difference, right? So it's true experiments must have control, randomization, and manipulation. What do these studies tell us? They allow the researcher to control the situation and helps in answering questions what causes something to occur. It permits the researcher to identify cause and effect relationships between variables and to distinguish the effects from placebo effects from treatment effects. It supports the ability to limit alternative explanations and to infer direct causal relationships in the study. It provides the highest level of evidence for simple studies. What these studies don't tell us is that this design is artificial and result may not generalize well to the real world. The artificial settings of experiments may alter subjects' behavior or responses, can be costly if special equipment or facilities are required, and some research problems cannot be studied using this method because of ethical or technical reasons, and difficult to apply ethnographic or other qualitative methods for this type of research studies. Eighth is exploratory, which is conducted about a research problem where there are few or no earlier studies has been done. So the focus is to gain insights and familiarity for later investigation or undertaken when problems are in a preliminary stage of investigation. So goals of this type of research is to have familiarity with the basic details, settings, and concerns, have a picture of the situation being developed, to generate ideas, new ideas, assumption, development of tentative theories or hypotheses, determine whether a study is feasible in the future. Issues get refined for more systematic investigation and formulation of new research questions, and direction for future research and techniques can get developed. What do these studies tell us? It's a useful approach for gaining background information about a particular topic. It is flexible and can address research questions of all types. It provides an opportunity to define new terms and clarify new concepts, some concepts, and also clarify some existing concepts. It's used to generate hypotheses and develop more precise research problems. It helps to establish research priorities. What do these theories, these types of research designs do not tell us? They generally utilize small sample size, and so findings are typically not generalizable to the population at large, and it prohibits us to make definite conclusions about the findings. It it is actually underpinning the exploratory the underpinning it underpins the exploratory studies here. It's flexible, but the process that is involved, what I mean to say is the process that is involved in this particular type of studies is flexible. The process, but it is often unstructured, which leads to only tentative results that have limited value in decision making. Now, it also lacks some rigorous standards applied to the method of data collection and analysis, because one of the areas of exploration could be to determine what method or methodologies could best fit to the research problem. Ninth is historical design, the purpose of which is to collect, verify, and synthesize evidence from the past to establish facts that either defend or refute your hypothesis. So it uses secondary sources and also a variety of primary documentary evidence such as logs, diaries, officials' records, reports, archives, non-textual information, right? So limitation is that the sources must be both authentic and valid. So this particular design is actually what happens is the act of this research does not affect the results of the study, is well suited for trend analysis. It can add important contextual background, which is required to understand a particular problem in a better way and interpret it in a better way. There's no possibility of the researcher being subject interaction, researcher subject interaction that could affect the findings, right? So there's no scope for it that there'll be interaction between the researcher and the participants, which will affect the findings. And it can be used over and over again to variety of research problems and replicate a previous study also. What they don't tell us. So the ability to fulfill the aims of your research are directly related to the amount and quality of document available to understand the research problem. And since historical research relies on data from past, there's no way to manipulate it to control for contemporary context. Interpreting historical sources can be time consuming. The sources used must be archived consistently to ensure access. Original authors bring down their perspectives and biasness in interpretation of the past events. And so it becomes very difficult to actually ascertain the what exactly is the real situation. It becomes because of this biasness, it becomes very difficult. So due to lack of control over external variables, this sort of research is very weak with regards to the demands for internal validity. And it is rare that the entire historical documentation needed to fully address a particular research problem is available for interpretation. So therefore, gaps needs to be acknowledged. 10th, longitudinal design. So it follows the same sample over time and makes repeated observations. So here what happens, the same group is interviewed at regular intervals, which enables the researcher to track changes over time and to relate them to variables that exactly explain why the changes have happened. So it describes the patterns of change and helps establish the direction and the magnitude of these causal relationships. And these measurements are taken for each variable over two or more distinct period of time, which helps any researcher to measure the changes in variables over time. So it's a type of observational study and sometimes referred to as a panel study. What do they tell us? The longitudinal data allows for analysis of duration for a particular phenomenon. It helps researchers to get close to the kinds of causal explanations, usually attainable only with experiments. And this actually permits the measurements of differences or change in variable from one period to another. So changes happen, right? It also helps in predicting the future outcomes based on the earlier factors. You can do that. What do these studies don't tell us? The data collection method can change over time. Maintaining the integrity of the original sample that you've chosen can be difficult over a period of time. It can be difficult to show more than one variable at a time. And this type of design usually often takes help of qualitative research to explain fluctuations in the data. It assumes present trends will continue unchanged, which does not happen. It can take a long period of time to gather data. There's a need to have a large sample size and accurate sampling to reach representativeness. 11th is observational design. So it draws a conclusion by comparing subjects against a control group in case where the researcher has no control over the experiment. So there are two types of observational design. Direct observation, people know how you're watching them. And the other type is unobtrusive measure is where you're studying the behavior of individuals and you do not let them know that they are being observed. So an observational study allows a useful insight into a phenomenon and avoids the ethical and practical difficulties of setting up a large and cumbersome research project. What do they tell you? These studies are usually flexible and do not necessarily need to be structured around a hypothesis, but what you expect to observe, right? If the data comes up on spot, it's emergent, it does not exist. The researcher is able to collect a depth of information about a particular behavior. It can also help in revealing relationships amongst multifaceted dimensions of group interactions. We can generalize the results to real life situations. It's also useful for discovering what variables are important before applying other methods like experiments. It also takes into account for the complexity of group behaviors. What they don't tell us, Reliability of data is low. Why? Because seeing behaviors occur over and over again may be a time consuming work, difficult to replicate. Now, findings may only reflect a unique sample population, may not be generalized to other groups. There can be problems with bias, as what happens, a researcher sees what they want to see. There's no possibility to determine the cause and effect relationship because since nothing is manipulated, the sources or subjects may not be all equally credible. A group that is studied is altered to some degree by the presence of the researcher. When they see the presence of researcher, the behavior changes as compared to when you know that nobody is watching you. When you are unobserved, your behavior is more normal. So what happens? Which would actually result in skewing to some degree of any data collected. Data can get skewed. The 12th one is philosophical design. So it's understood more of as a broad approach to examine a research problem than a methodological design. Philosophical analysis and argumentation is needed to challenge some deeply embedded assumptions on an area of study. So it basically uses tools of argumentation derived from philosophical traditions, concepts, models, and theories to critically explore challenge, right? So how it's been done, it's been this tool of analysis can be framed in three ways. One is ontology, with the study that describes the nature of reality. For example, what is real, what is not, what is fundamental, what is derivative. Epistemology is the study that explores the nature of knowledge. Say, for example, what does knowledge, what does knowledge and understanding depend upon? How can we are certain of what we know? And the third is axiology, the study of values. For example, what values does an individual or group hold and why? What does these studies tell us? They provide a basis for applying ethical decision making to practice. It functions as a measure of gaining greater self understanding and self knowledge about the purpose of research, brings clarity to general guiding practices and principles of an individual or group. Philosophy informs methodology, refines the concepts and theories that are invoked in relatively unreflective modes of thought and discourse. Beyond methodology, philosophy also informs critical thinking about epistemology and structure of reality. It helps in clarification and definition to the practical and theoretical uses of terms, concepts, and ideas. What these theories don't tell us: limited application to specific research problems. Analysis can be abstract, argumentative, and limited in its practical application to real issues, while a philosophical analysis may render problematic that which was once simple or taken for granted. Writing can be dense and subject to some unnecessary jargon, overstatement, over excessive quotation, documentation. There are limitations in the use of metaphor as a vehicle of philosophical analysis, and there can be analytical difficulties in moving from philosophy to advocacy and between abstract thought and applications to the phenomenal world. So that problem comes up. Okay, the last type of research design is sequential design, which is carried out in a deliberate staged approach. One stage will be completed, followed by another, and so on. That's how it goes, with the aim that each stage will build upon the previous one. So each stage depends on the previous stage until enough data is gathered over an interval period of over a certain interval of time to test your hypothesis. And the sample is not predetermined. After each sample is analyzed, the researcher accepts or rejects the hypothesis, then select another group of subjects and conduct the research. Okay, so it can go on for a limitless number of subjects until making of final decisions whether to accept or reject the hypothesis. What do these studies tell us? The researcher has a limitless option when it comes to sample size and the sampling schedule. And due to repetitive nature of this research design, minor changes and adjustments can be done during the initial parts of study to correct and hone the research methods. There is very little effort on part of the researcher when performing this technique. It's not expensive, time consuming, or workforce extensive, and because it is conducted serially, the results of one sample are known before the next sample is taken and analyzed. What do these studies don't tell us? The sampling method is not representative of the entire population, right? Because the sampling technique is not randomized, the design cannot be used to create conclusions and interpretations relating to the entire population. Difficulty to account for and interpret variation from one sample to another over a period of time, particularly when using qualitative methods of data collection. So we go to the next part of research design, that is measurement of variables. Measurement of variables. Measurement, what does it mean? The assignment of numbers or other symbols to characteristics or attributes of objects, according to a pre-specified set of rules. Objects here means could be persons, strategic business units, and companies, countries, bicycles, elephants, kitchen appliances, and so on and so forth. When we talk of characteristics of objects, it could be like arousal, seeking, tendency, achievement, motivation, organizational effectiveness, shopping enjoyment, and so on and so forth. So measurement, right? Uh, attributes of subjects, attributes of objects that can be physically measured by some instruments which pose no measurement problem. Say, what are you measuring? Length and width of a table. That can be easily measured with what? With a measuring tape or a ruler, where you do not have any problem of measuring. And the data representing demographic characteristics of employees are easily obtained. How? By asking employees question. How long have you working in this organization? What is your marital status? Abstract and subject variables are harder to measure. That is motivation, effectiveness, happiness, love. It's difficult to measure. So these are the levels of scale measurement. Comes at the beginning is nominal, which is attributes are only named, so it's the weakest. Then comes ordinal, where the attributes can be ordered. Then comes up interval, where the distance is meaningful, ratio is absolute zero. So what is scale? When we say scale, scale is a tool or mechanism by which individuals are distinguished as to how they differ from one another on the variables of interest or study. So it helps us in distinguishing how they're different. See this? This is an example measurement of skills. Where nominal is where you just see, talk about this person. One ordinal is where you are. What are we showing? We are showing the position, right? Where, how. We show the place and when. Interval is where we are showing it. Then time interval, where it is after such time, after 20 seconds, and when it's winning, when the time. Ratio, where we are saying 1 minute 59 to seconds for 1 1/4 miles, where you're comparing it. Here you're just showing it, showing the presence. There you're looking into showing the position, so you're saying initially where it is and then when it's winning, showing the positions. Here you're showing the time comes up after 20 seconds where it is and then when it's winning. And here we talk of ratio. So nominal is places data into categories with no order, often uses names, numbers with no numerical values, male or female, employed, unemployed. So from statistical viewpoint, it's the lowest form of measurement. See, for example, what is your department? Just see. Ordinal is allows you to arrange things based on how much some concept they possess. You are able to show your preference allowing it, so it allows the researchers to identify the order of a factor without relative positional factor. Say top three Olympic runners, showing them the fastest runner may be far superior to second, but there's no way to represent this, just showing, identify the order. What is the highest level of education you have? So you just say interval is which has both nominal and ordinal properties, that captures information about differences in quantities of concept, that it reveals the order and the interval. See this? Saying 1 degree Celsius here is equal to 1 degree Celsius here. So sees the order. as well as the difference, it says. Ratio is has properties of interval scales with the additional attribute of representing absolute quantities. A scale that has a true 0 point, right? So scale, you're talking scale and absolute value. No, not it's not commonly used or found in social research. Sample time, measuring reaction time in milliseconds. We get a value from 0 and we can conceptualize less than 0. A 2 second reaction time is exactly double to a 1 second reaction time. So that's where it comes up. So ratio comes. Right. Next, learning partner activity. So this is an example for you where you need to find out which is nominal, ordinal, interval, or ratio. Right. So we continue with measuring attitudes. Attitude. What is attitude? It's an enduring disposition to consistently respond in a given manner to various aspects of the world. Okay? You respond in a given manner to different aspects. So, what are the different components of attitude? Cognition, where knowledge and belief about a object, situation, or person. Affect, it's the feelings or emotions towards an object, situation, person. And behavior is predisposition to predisposition to action, intentions, behavior, expectations. Why do we measure attitudes? Because most managers are of the belief that changing consumers' be or employees' attitudes towards their company or the company's products or services is a major goal, right? That helps, like the in designing, making their future decisions, and the measurement of these attitudes is an important task. Why? Because modifying attitudes, it helps. It helps in playing a major role, which whereby it helps in addressing the strategies to address these goals. The companies can actually develop the strategies how to actually measure these goals that change in attitudes that comes up. So how do we measure attitudes? One is ranking, requiring the respondent to rank the order of checks in overall performance on the basis of a characteristics or stimulus. It could be on the basis of rating, where you ask the respondent to estimate the magnitude of a characteristic or quality that an object possesses by indicating on a scale where he or she would rate an object. Sorting, presenting the respondent with several concepts typed on cards and requiring the respondents to arrange the cards into a number of piles or otherwise classify it, to group it. And choice, asking the respondent to choose one of the alternative from from the several alternatives. It's assumed that their chosen alternative is preferred over the others, right? So see, attitude rating scales, a simple attitude rating scale which requires an individual to agree or disagree with a statement or respond to a simple question, one single question. So, and this particular type of rating, it actually classifies respondents into one of the two categories, either yes or no. Say, president should run for election, re-election, agree, disagree. Category scale, second type, it's a much more sensitive measure where it can have more than two response categories. How important were the following in your decision to visit San Diego? Climate. So three things, very important, somewhat not. So you come up, right? More than two. Third type is method of summated ratings. It's like when we talk of Likert scale. It's a very popular means of measuring attitudes. Respondents indicate their own attitudes by checking how strongly they agree or disagree with some statements. So some of the typical response alternatives is strongly agree, agree, certain, uncertain, disagree, strongly disagree. So example, you see, it's more fun to play a tough competitive tennis match than to play an easy one. So you have a five, scale of five where you choose. And the last type where we have a semantic differential scale. It's a series of 7 point rating scales with bipolar objectives, that is good and bad, right? Two ends. A weight is assigned to each of position on the scale. So it could be from 7, 6, 5, 4, 3 to 1, from 7 to 1, or it could be from +3 to -3. Okay, so you have to say exciting and calm. Where do you put yourself? So of these factors. Okay, there can be other type of rating scales also. One is the graphical scale, which is a measure of attitude, which allows respondents to rate an object by choosing any point along a graphic continuum. So this is worst possible line, best possible. You place it. It allows a researcher to choose any interval desired for scoring purposes. See, happy scale, happy face scale, very poor. This somewhere in the middle, very good. So you just see it. Right. Next we come to population and sampling, where we talk of population and sample. This is where it is. Okay. So sampling is we can. Why are we talking of sampling? See this cartoon. Just as I suspected, we are going to need to take more blood, right? So taking a sample and just looking into it. So we can't always examine the entire population, right? Why it's huge, entire populations, everyone. So how do we go about? Solution is sampling. But we need to make sure that the sample is representative. So when it says just as I suspected, we are going to need to take more blood. So this is only with regards to the person, not for the entire population. So what is population? It's the entire group of people, events, or things of interest that the researcher wishes to investigate. So it's a group of people, entire group of people, events, or things of interest which the researcher wants to make inferences and based on sample statistics. So element is a single member of the population. Every single member of the population is called element. Sample is a subset or subgroup of population. Say, for example, if there are 150 elderly people living in a nursing home, and 30 of them have to be interviewed by the nursing home administrator to assess the level of satisfaction where the food is concerned. So this 30 is called sample, right? And 150 is the population. Every single member of the population is elements. So every single member, all these 120 people are elements. They're interviewing 30 people, so that is called sample. And each member of the sample, that 30, each of these 30 members are called subjects. That's individual member of the sample. Sampling unit, it's an element or set of elements available for selection in the sampling process. So what is sampling? It's a process of selecting a sufficient number of the right elements from the population so that the results from analyzing the sample, it makes it possible to generalize to the population, right? So analyzing the sample means where you understand the properties, its properties and characteristics, and from there you can make your general conclusion about the sample. So what do you do? How do we go about with the sampling? We first define the problem, population, then determine the sample frame, then determine the sampling design, determine the appropriate sample size, and then execute the sampling process. So this is the entire population. This is a sample. So case or element means members of the population. So defining, when we talk of defining the population, is defining the target population in terms of elements, geographical boundaries, and time. When we talk of sample frame, it's the objective list of population elements. List of population elements from which the sample will be drawn. Registry of all students, staff at a university, for example. Now there can be two types of sampling design, probability sampling and non-probability. When we talk of probability sampling where the elements of the population have a known and a non-zero chance of being chosen as sample subjects. Either you can be chosen or not. When we talk of non-probability sampling, here what happens? Elements in the population do not have a known and unknown zero chance of being selected. It's already decided. It's your own judgment comes out. So sampling design, right? When we talk of probability sampling, it could be simple random sampling, systematic sampling, stratified sampling, cluster sampling, where the representatives of the sample is of importance in the interest of the wider generalizability of the findings. So Let's go into more of it, like what we just discussed, the probability sampling. So simple random sampling is where each element has a known and equal chance of being selected. They are highly generalizable, least bias, easy to understand, easily understood, reliable, population frame necessary, no, or not always practicable. Systematic sampling is where each nth element, starting from a random choice of an element between 1 and n. So you pick up first is a random choice. There are n by n number of people in that sample in that population. So you pick up the first randomly, then the nth number element is being selected. So it's easier than simple random sampling, and systematic biases when elements are not randomly listed. Stratified random sampling, where what happens is that you divide the population into different strata, include all strata, random selection of elements from the strata. So you pick up from the strata, divide it into strata, then pick up. Proportionate, it could be proportionate, it could be disproportionate also. And you select from the strata, either proportionately or disproportionately. And the characteristics when we say is interstrata, there should be heterogeneity. Intrastratum, there should be homogeneity and includes all relevant subpopulations. Cluster sampling. So, cluster sampling, divide the entire population into clusters, and where you randomly select the cluster as such and include all the elements from selected clusters. Unlike here, strata, what happens is like when you have the select the elements from strata, from not take a particular strata. All the different strata is included, but not everyone. But from each strata, you pick up some people, some of them, some of the elements, right? So the characteristics here is intercluster homogeneity, intracluster heterogeneity. It's easy, convenient, and cost efficient, and it's low correspondence with reality. So, the second type of sampling design is non-probability sampling design, which is convenience sampling, judgment sampling, and quota sampling, where researchers may at times be less concerned about generalizability than obtaining some preliminary information in a quick and inexpensive way. So, as a sampling technique, qualitative research generally uses a non-probability sampling because it's here where they do not aim to draw statistical inference. So, non-probability sampling is one of the techniques which is employed in qualitative investigation where subjects are selected on the basis of the expertise in the subject that is investigated. So, it's important that the subjects are chosen in a way that they reflect the diversity of the population. So more on details on the non-probability sampling. The three types. So convenience sampling, it's collection of information from members of the population who are conveniently available to provide it. Say shoppers at a shopping mall, delegates attending a trade show would give more information. Convenience sampling is most often used during the exploratory phase of research project. It's considered to be the best way of getting some quick basic information very quickly and efficiently. Judgment sampling, it's where it involves subjects who are best placed to provide the information. Say expatriate employees, women managers, subjects who could reasonably be expected to be expert in that area. They have the expertise knowledge by way of having the right experiences and the processes involved. They've undergone those processes. They might probably be also be able to provide better information. That's why and provide the better data to the researcher, and it's used only when there are limited number of category of people have the information that is sought. Very few people have those information. That's when you go for judgment sampling, and it may restrict the generalizability of findings because experts opinion, few people's opinion. Quota sampling is which ensures certain groups are adequately represented in the study through the assignment of quota. It's used when a subset of the population is underrepresented by minority groups and organizations. So you look into that. May not be totally representative of a population, therefore it restricts generalizability of findings. Quota. Certain groups. where it is underrepresented or happens, right? Or their opinions are not taken into consideration. So the sample size, right? When choosing a sample size, what you have to consider? The degree of accuracy required, the sensitivity of the measuring instrument, the time and budget. So in general, what happens? The sample size should be somewhere between 30 and 500. And if you talk of categories, it's 30 per subcategory. Multivariate could be 10 into number of variables. Experiments could be 10 to 50 per condition. So this is the general thing. So you need to remember something, that sampling design decisions are important aspects of research design and includes both the sampling plan and the sample size. Whereas in case of probability sampling plans, they lend themselves to generalizability, and non-probability sampling designs offer convenience and timely information. Okay, so that's what we have here, right? And I'll see you in class and next week.